Hey guys, so this is a new screen for you, and this is our online algebra book that you'll start using at home, so please remind me to help you get logged on. And if you're in period 8, do not forget that I need you to take your books back so that we can have a class set. But we're looking at this question number 10. This is the practice problem for finding slope. A hot air balloonist gathered the data in this table. What is the slope of the line through these points? So I want you to write down 2 of these points. So I'm going to write down 0 and 14 because it's 0 minutes, there are 14 meters. And then I'm also going to write down the point 2.2, comma, 80. So I'm going to switch over to where I just wrote those down. And we're going to use what we just used, which was the slope formula. Okay, so I'm gonna label these x1, y1. Every point has an x and a y, a rise and a run. And I'm going to label this x2, y2. And if you have your notes open still in front of you, you should, because you're doing this on the next page, so you can look at them. You remember the formula for slope was y2 minus y1 over x2 minus x1. So let's substitute these numbers in. y2 is 80 minus y1 is 14. So 80 and 14. What's left over? If we have y2 on the numerator, if we used this one first, we use this one first on the denominator. So 2.2 minus 0. Okay, so 80 minus 14, let's do this quickly. 80 minus 14, 66. On the numerator over, I can do this in my head, 2.2 on the denominator. Now let's divide, and we get 30. So my slope is positive 30. What's the next? So that was question 1. What is the slope? Or A, I'm sorry, what is the slope? What's B? B says, what are the units of the slope and what is the real world meaning of the slope? Well, look at the table. Sorry, you guys. Look at the table. We have time in minutes, so the units of the slope are minutes and meters, right? Time in minutes, height in meters. So if our slope is 30, what does that mean? It's the rise over the run. So it's the rise 30 meters every 1 minute. Okay? Let's go back over here. So what does that mean? Our time was in minutes, the number of minutes, and our height is in meters. So our slope is 30, right? We can always write that as a fraction. And remember what I told you, the rise over the run, or y, the change in y over the change in x. So the change in y is our height. So the change in y, I could say for every minute we rise 30 meters. So for each x minute, we go 30 meters higher. Okay, so for every x, how many y do we go, right? All right, let's go back and look at C. Write the linear equation in intercept form to model the situation. So luckily we know how to do that. We know a linear relationship from last unit is y equals mx plus b. We have most of it. We have our slope. We know that's 30 right? 30 meters for every, and X stands for minutes. And what is our y-intercept? Well, we could see that from the table. Let me switch back really quick. Look, it says when we have 0 minutes, our height is 14. So our y-intercept must be plus 14. Cool, we're just cruising along. Question D. What is the height of the balloon after 8 minutes? Good question. Let's use our formula. Y is the height, X is the minute, so we want after 8 minutes, so 8 minutes is X, right? So we're going to put Y equals 30, but instead of times X, we have times 8 plus 14. So if we just do that, 30 times 8, I can actually do that in my head. It's going to be 240 plus 14. I don't want this to be wrong, so we're going to have 240 plus 14, 254. So after 8 minutes, the balloon will be 254 meters high. Okay? Is there an E? One more. During what time interval is the height less than or equal to 500 meters? So we know at 0 it's less than 500 meters. So let's figure out when it will reach 500 meters. So this time we have to solve it, instead of solving for X, we need to solve for X. We have Y. Last time we had X, we needed to solve for Y. So easy enough. If we just enter it into the equation, then we just solve it like we did last unit. So this time we know how many minutes, we want to know how many minutes will it take to be 500 meters. So this time we have to kind of, oops, sorry about that. This time we really have to solve and not just evaluate, not just be able to enter that in. So subtract 14 from both sides. And this should be 486. 30 times X. Let's hope my technology works here. Then we divide both sides by 30. Divide, this is a 6. Divide by 30. I'm going to move over here. So now my 30s cancel out, so I have X equals, X equals 486 divided by 30. I need help. 486 divided by 30. 16.2. Remember, X stands for minutes, so in a complete sentence, the interval will be below 500 meters between 0 and 16.2 minutes. I don't have enough room to write that, so I hope you listen to that. The interval, it's asking for an interval, is between 0 and 16.2. 0 and 16.2 minutes. All right. Let me know if you have any questions.